Welcome to Africa Teen Geek Online School. This is the STEM Digital School. So if you have just joined in, this is the Africa Teen Geek STEM Digital School. You are here for grade 11 physical sciences. If you have just joined in, you are here for grade 11 physical sciences. I hope that everybody is in the right place. Today is the 22nd of July 2020. And yesterday we were supposed to start with applying Ohm's law, but it seems that the problems that we did for the electric field strength actually took all of our time yesterday. So we need to do it quickly today because, as you know, tomorrow we're having assessments, and the assessment we're going to start at exactly 11 o'clock. And please, guys, make sure that you are prepared and you understand the work. The most important thing is for you guys to test yourself. We will go through and I'll make sure that the whole lesson, I give it to you guys to attempt these questions that I've set up for you guys. But the aim is not to see you guys fail or to see that you guys don't understand, but for you guys to be able to test yourself and see what is it that you understand and what is it that you don't. Okay. So please, guys, be in check with that. So that's going to be happening tomorrow. So today, hence, we have to just finish up the Ohm's law and make sure that at least you guys understand. I'm not going to ask anything further than this. We are not done with this chapter with the calculations, but I'll do a test that ends on these Ohm's law application. Okay, reminding you that I'm working on in this Siavula textbook. I'm working on the study and master textbook. So if you have either of these textbooks, you're on the right place, or any other CAPS approved textbook. But if you feel like you do not have and the textbook that you're using doesn't give you all the information that you need, then you can just download Snaplify. Snaplify is an application where you can download all types of textbooks, and they've made it absolutely free until the 31st of December 2020 because of the COVID-19 issues. Okay, so just reminding you guys again is that for this part that we're doing, right now we are doing electricity and magnetism. As much as we're going to study past paper, etc., we're going to make sure that we do not do the calculations for electromagnetism. So electromagnetism, we're only going to do the theory part because it has been removed from this syllabus for this year. So just take advantage. We'll do for electricity and electric currents, but for electromagnetism, we won't be having calculations. Okay. So let's get on to it. What is Ohm's law? Guys, this is just a revision of theory. Remember, we did all the theory. Last week we even did all the revision for theory for all these chapters: electricity, electrostatics, electric circuits, and electromagnetism. So now I'm just bringing in the law so that you guys can understand, just to refresh for the problems that you guys have to do. Okay. So the Ohm's law in this case is the amount of electric current through a metal conductor at a constant temperature. Always mark this part, okay? So the Ohm's law applies at a constant temperature. But if it's not a constant temperature, then you're going to use the other formula of PVI, etc. Okay? So this one is the amount of electric current through a metal conductor at a constant temperature in a circuit is proportional to the voltage across the conductor and can be described by I is equals to voltage divided by resistance. I is being the current, V being the voltage across the conductor, and the R being the resistance of the conductor. So in other words, at constant temperature, the resistance of a conductor is constant, independent of the voltage applied across it or current that passed through it. Okay. So those are just small definitions. So the most important things that matter right now in this part of the calculation where we're doing electric circuits is the circuit itself. So usually we're going to start with a circuit that has resistors in series. Okay. So there's two specific parts that we're going to be dealing with is resistors in series and resistors in parallel, because they determine how you do your calculations in an electric circuit. Okay, so when you have a circuit, you will have something like this. So this basically is an electrical circuit. So what happens here is that you've got your resistors that will be placed in any order, but in this case, they've placed it in series, right? And what they basically said in ohms is that if this conductor is this line here, it represents your conductor, and this is your source, right? So it could be a battery, etc. And your resistors could be a load, it could be a light bulb, etc. So that is your load. So if you have a circuit of this nature, it says according to the Coulomb's law, to the Ohm's law, that the voltage across the conductor, so you see the voltage is being placed across the conductor, is parallel to the current. Okay, it's proportional to the current. So you see, it's proportional to the current and inversely proportional to the resistance. So which means that if you had to calculate R, you'd say I current is equal to velocity divided by resistance, indirectly proportional and proportional. Okay, so that's basically what the Ohm's law states. But obviously, as you know, with all calculations, there's always conditions that influence extensions of calculations, or a change in how we have to calculate certain things. So for N resistors, okay, so in series is the definition of equivalent resistance in series circuit. For resistors in series, the equivalent resistance will be the sum of individual resistances. Okay, it will be the sum of individual resistances. In this case, it will be R1 plus R2 plus R3. Okay, but if you check here, you see the current. Remember I told you guys that whenever you measure, this is your ammeter and this is your voltmeter. So this is not your voltage, it's a voltmeter. It's calculating the value of your voltage across the conductor of the resistance. And your ammeter is not your current. It's an instrument that's used to calculate your current across your current in series to the conductor. So whenever you place these two, you always put a voltmeter in parallel to the circuit and your ammeter in series to the circuit. Okay. So if you check here, you see that this is in parallel, right? So which means that if these individual resistance are in series, it means that the equivalent equation for resistance is going to be R1 plus R2 plus R3. But resistors in series are voltage dividers. Why are they voltage dividers? Because the sum of this voltage across here is equals to the individual voltages of each resistance. So it's going to be the total voltage is equals to V1 plus V2 plus V3. So it's a voltage divider. So the current in each of these, because these are in series and the current is also in series, the current is going to be equal. So basically here, your I1 is going to be equals to I2 is going to be equals to I3, and you'll also be the same as your current that is over here. Okay, so what is an equivalent resistance? Equivalent resistance is the resistance of a single resistor that can take the place of a number of resistors joined together. So here, when we're doing this RS, we're actually looking for our equivalent resistance. So we're going to place one block of resistance there that is already calculated, and we're going to call it RS, which means R series. So that will be our equivalent circuit, our equivalent resistance after we have calculated according to the Ohm's law and the definition that says that in series RS is equals to R1 plus R2 plus R3, and then we just put one block there, and that's going to be our R equivalent. Okay, if you don't understand, guys, you are free to send a chat. You need to understand these things, especially for tomorrow. So here's a quick example for a resistance in series. So it says figure 3 shows 3 resistors connected in series in a circuit. The ammeter, which is here, remember I said it's the ammeter, it reads how much current is flowing in a circuit in this case. So they want to know if the ammeter reads this amount of current, determine the equivalent resistance. Okay, So what do we know about this? We know that our current, we don't have to calculate it because it's the same in a series circuit. So here it's also going to be 0.3, 0.3 amps, 0.3 amps, because the current is the same in the whole circuit in a series circuit. So the equivalent resistance here is going to be Rs is equals to R1 plus R2 plus R3. And there is going to give us an answer of 60 ohms. So the reading on the voltmeter, remember what we said about the voltmeter for a series? We said it's a voltage divider. A series circuit is a voltage divider. So we're going to have to say V is equals to V1 plus V2 plus V3. So what are we going to do? V in this case is going to be equals to I times R. So it's going to be 0.3 times 10, 0.3 times 30, 0.3 times 20, and then we're going to add them all together. As you can see, that's what it's been done here. Okay. You can do that, or if you have already calculated, remember we've already calculated our R series, so we don't have to do it individually anymore because we've got our equivalent resistance, which has been calculated over here. This is our equivalent resistance. So now for voltage, we can just say I times R, and it will give us 18. And the reading on the voltmeter is 18 volts. Looks pretty simple, right, guys? I hope that it makes sense to you guys. So moving on, now we're moving to circuits with resistors in parallel. This one is slightly different and a bit more complicated than the resistors in series. So equivalent resistance in parallel circuit, for n resistors in parallel, the equivalent resistance is equals to 1 over R parallel is equals to 1 over R1 plus R1 over R2 plus 1 over R3. So this becomes a bit tricky, especially if you have to calculate it, because you're going to have to find the lowest common denominator for these three. And at the end of the day, you need to cross multiply to get this one as the subject of the formula. But we're going to do an example that's going to explain it further. So the total resistance in a parallel circuit will be that we've just stated now. The resistors in parallel are current dividers. So in this case, remember before for series, we said they are voltage dividers because the current is the same in the entire circuit. But in this case, the voltage is what is equal in all stages, because you see with a voltage you can only calculate it across. So if you find it across here, it's going to give you the same voltage, okay, on both sides. But for the current, we're going to use the current divider rule, which is going to be I parallel is here, is equals to I1 plus I2 plus I3. So they divide in this case, okay? So it's going to be the total that you're going to use to find your I parallel. Does it make sense, guys? If it doesn't, just drop me a chat and I'll explain it further. So then we get to an example. Example says it shows 3 resistors connected in a parallel circuit. So the voltmeter reads 3 volts. So determine, number 1, the equivalent resistance, and number 2, the reading on the ammeter. So the first method that we're going to do, we're going to try and calculate the resistance. So here it is. Here is how we calculate the resistance. We're going to say 1 over R parallel equals to 1 over R1 plus 1 over R2 plus 1 over R3. And therefore, it's going to be 20, 30, 20. So what's going to be our lowest common denominator here? Our lowest common denominator is going to be a 60, right? And then here's going to be 3, here's going to be 2, and here's going to be 1. So we're going to have it like this, right? It's going to be 8 over 60. So for us to get the R parallel as the subject of the formula, you're going to swap them both around. So the R is going to be the top, and then now it's going to be 60 over 8. So our R equivalent for our parallel circuit is going to be 7.5 ohms. Okay. I hope it makes sense to you guys and how this was found. So now that we've got our R equivalent, it means that we can place it in that small box again now. We can have our small box that represents this R parallel. So now we need the reading on the ammeter. Remember, it's a current divider. So now we're going to look for the current, not the voltage. So this is going to be VP is going to be 3 volts and RP is going to be 7.5. So what we're going to do, we're going to select the equation. Now we're looking for current. So we're going to substitute the values. So it's going to be 3 volts divided by 7.5 ohms. This is going to be 0.4 amps. So the reading on the ammeter is 0.4 amps. Okay, are we together? So now, because we still have time and this was supposed to be done yesterday, this could have been homework, but now it is classwork. So I'm not going to do the first and the second one, where it says write the meaning of the following words or terms: resistance, ohmic, conductor, non-ohmic conductor, equivalent resistance, resistance connected in parallel, and resistance connected in series. The only thing that I can say is that this resists the flow of electrical charge, or it limits, okay? And the ohmic conductor is a conductor that obeys the Ohm's law and is at constant temperature. And non-ohmic conductor is a conductor that does not obey the Ohm's law and it's not at a constant temperature. Equivalent resistance, we've already spoken about it. And equivalent resistance is um, um, a single resistance that represents the individual resistance that have been calculated either for parallel or series resistances. Resistors connected in parallel are resistors that are connected in a parallel formation whereby 1 over R parallel is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So these ones are resistors connected in a parallel arrangement in an electric circuit. Resistors connected in series is resistors that are connected in a series arrangement, so next to each other in a electrical circuit, whereby the resistance, the total resistance in series will be R1, Rs is equals to R1 plus R2 plus R3. Okay, so state the Ohm's law. This one you've already stated it. I'm sure you know it by now, but I'll give you guys a hint. Is that the Ohm's law? You just have to look at I is equals to V divided by R. So when you break that down, what are you going to say? You're going to say that in an electric circuit with constant temperature, the current is directly proportional to the resistance, and the current is also indirectly proportional to the resistance in the circuit. Okay, so number 2.2, we move on. A length of a resistance wire is an ohmic conductor. When the voltage across the wire is 5 volts, the current is 0.5 amps. Calculate the current if the voltage across the wire is 12 volts. Okay, so what do we have? Say the length of the resistance is an ohmic conductor, so which means that it obeys the Ohm's law. When the voltage across the wire is 5 volts, the current is 0.5. So what they want here is for you to calculate the current if the voltage across the wire is 12 volts. Okay, so which means that if it's across this wire, it means that you can find the resistance using this too. You can find the resistance, and once you find the resistance, now you can calculate the current. So let's go and check that out. Okay, so here we have it. So the initial and final ratios of and currents are the same, right? So it says V1 over I1 is equals to V2 over I2. So now we're substituting. On the one side, we have 5 volts and 0.5 amps. But on the other side, we've got 12 volts, but only one. We do not know what is the current. So basically, that will be easy to find the current, right? You're just going to cross multiply, and your answer is going to be 1.2 amp. Okay. So basically, you use the ratio because it's still the same wire. They haven't changed the wire. It just changed the amount of voltage across the wire. So that's why we're using a ratio formula. Okay. So number 3 says state the relationship for A voltage and B current for a series connection resistance. So the relationship for voltage in a series is that it's a voltage divider in a series circuit, and for A, yes, 3.1A, it's a voltage divider in a series circuit, and the the voltage across the circuit will be V is equals to V1 plus V2 plus V3. But for the current is the same across the whole series connection of resistors. So I is equals to I1 is equals to I2. So for a parallel connection of resistors, we know that it's a current divider. So the currents are the sum of the total current is the sum of individual currents on the resistor. So I total is going to be I1 plus I2 plus I3. But when it comes to the voltage is equal across the entire circuit. So which means V is equals to V1, it's equals to V2 is equals to V3. Okay, are we good to go? So on number 4, it says an electric kettle is connected to a 220 volt main supply. If the current through the element of the kettle is 9 amps, calculate its resistance. So this one is a dead given, right? It's very much given because you've got your voltage and you've got your current. The only thing that they want is a resistance. So you can use your Ohm's law. Your Ohm's law is going to be resistance is equals to voltage over current. And let's see what answer we're going to get there. Okay, so here it is. Step 1, you list the variables. Why do we do this? Because sometimes we're not always going to have, the reason why we do steps is because we're not always going to have a simple question that needs an equation, okay? So sometimes it's complex, so it's always good to do them step by step. So first of all, you're going to list the variables, which is going to be our voltage, our current, and we're looking for our resistance. So we're going to select an equation, which is going to be R is equals to V over I. Guys, it's very important that you guys do them step by step because you could get marks for each step that you place in there, okay? You're not going to just write an answer and get 4 marks or 5 marks. They're going to mark it step by step. So you substitute the values. So R is going to be equals to 220 divided by 9. And when you simplify that, it's going to give you 24.44 ohms, okay? So the answer, resistance of the element is 24.44 ohms. Okay, I hope that we all understand it. Okay, so an element, basically electricity, it's a sealed heating resistor of a stove, kettle, or hot water geyser. That's a new word that you guys can place in your vocab. So number 5 says a torch bulb has a resistance of 16 ohms. A torch bulb has a resistance of 16 ohms. Calculate the current in it if the voltage across it is 3.2. This one is also very simple. You've got your given, you've got your variables, you've got your resistance, and you've got your voltage. So you can calculate your current. You go back to your original formula of Ohm's law. It's going to be current is equals to voltage divided by resistance, and that's going to be 3.2 volts divided by 16. And that's how you're going to have your answer for number 5. So you see, it might be written in step by step, but it's quite simple to do because you've got all the things that you need. It's not complicated. It doesn't have, you know, parallel or series circuits that you have to solve first. Okay. So now we move on to number 6, which says it shows 3 resistors in a circuit. Okay. So now we're moving on to a series calculation. So there is, you've got your battery there, you've got your ammeter there, but you've got your voltage for your individual resistance because they are in series. So what they want to know first is calculate the resistance of R1 if voltmeter V1 reads 4 volts. Okay, so how are you going to do this, guys? Okay, we know that for R1 it's going to be equals to V1 divided by I. Okay, it's going to be V1 divided by I. But we know that I is already a dead given because our current is the same across the whole circuit. So we don't have to calculate our current. So it's going to be V is equals to is going to be equals to, where is it? It's going to be 4 divided by 2, and that's going to be 2 ohms. So number 6.2, determine the reading of the voltmeter V2 if R2 is 6 ohms. So in this case, it's vice versa. Now we're looking for the resistance. Now now we're looking for the voltage. So V2 is going to be I times R, which is going to be equals to 2 times 3, and that's going to give us 6 volts. Okay. So 6.3 says calculate the resistance of R3. Okay. So the resistance of R3, there's many ways to find it. You can even say V total, which is this 12 right here. V total is equals to V1 plus V2 plus V3. And we make V3 the subject of the formula. So it's going to be 12 minus 4 minus 6. And that's going to give us the voltage for R3. Then now we can go straight to looking for the resistance, which is going to be equals to V divided by R, which is going to be what we got from finding this divided by the 2 amps. So let's go and check that out. I just wanted you guys to explain quickly how that worked out. Okay. 6.26. Okay. So there we have it. First, we found the resistance for R1, right? They wanted the resistor for R1, which was 2 ohms, and they wanted the voltage for R2, and we got that as 6 volts, like we already mentioned. So now, part 1, calculate the voltage across R3, right? And like I told you guys, we're going to first have to find the voltage, because that's the only thing we don't have for us to calculate it. So we're going to say Vs is equals to V1 plus V2 plus V3, and we're going to substitute it by 12 is equals to 4 plus 6 and plus V3. So we're going to take this to the other side. So our V3 is going to be equals to 2. That's the first part. So now we need to take our first part and merge it into the equation of Ohm's law. So calculating R3, now we've got both our voltage and our current. So we're going to select an equation. It's going to be R is equals to V over I. Substituting the values, it's going to give us a resistance of 1 ohm. Okay. So we're moving on, guys. I'm trying to move on quick so that we can not be lost of time. So we're moving on to number 7, right? So number 7.1 says, explain why the equivalent resistance of resistors connected in parallel is always lower than any one of the resistors alone. Because they're dividers, they're dividing, right? It's always 1 over R1. Okay, but let's check out. And then number 2 says, explain why resistors connected in parallel are called current dividers. That one we've been on about it. They're called current dividers because they are individual. They are the individual sum of the resistors connected in parallel. So come, let's see what they say. So connecting resistors in parallel provides additional path for the current, and the equivalent resistance becomes less than any one of the resistors. Okay, because they divide amongst it. It has to divide into the circuit. So that's why it becomes less. And then why is it called current divider? The current splits to go through the resistors. So it has to split equally. Okay. Then we're moving to the next question, which is number 8. Oof. Okay. So this one is a sport of a question, isn't it? So calculate the equivalent resistance of each of the parallel connects. This is a great one for you guys to do exercise, okay? Because this one is parallel. You're going to use a parallel. So these are all parallel actually. So let's go and number 8, right? So here we are. So it's always important, guys, please do practice calculating your parallel resistors because they are a problem, hey? Especially if you've never tried it, it's easy to make a simple mistake with these ones. So make sure that you are clear on how to do that. So you're going to put them, remember they all go into the denominator, right? In the first state. And then Now you have to have a common denominator. But remember, when you get to the common denominator, if this, for example, is a 4, you're going to have to say, change this into a 4, but now we're going to have to times the top part by a 2, because 2 times 2 gives you 4. Then we have our lowest common denominator, and it's going to be 2 over 3. Then it's going to be this. But now we need to swap them around in order to get the R parallel as the subject of the formula. So it's going to be 4 divided by 3, and that will give you 1.33 ohms. Okay. So let's do it for the second one again. This one, the second one also takes the same procedure as the one that we just did now. You're going to say 1 over R parallel is equals to 1 over R1 plus 1 over R2. And what's the lowest common denominator here? It's going to be 40. Imagine. That's where your maths comes into play here. Then it's going to be 40. So for this to be 40, you have to times it by 4. So here it's going to be times by 4 on your numerator side. And on this denominator, for it to be 40, you need to times it by 5, and which means you'll have to times by 5 on the top as well. Okay? Therefore, it's going to be 9 over 40. But because we need to swap it around to make R parallel the subject of the formula, then it's going to be 40 divided by 9, and that's going to give us 4.44 ohms. Okay. I hope that everybody is following through. Let's go to the next one. Next one. I think we've got a little slow jam here. Okay, here we are. So that is the last one. This one has three resistors in parallel, right? So we're going to do the very same procedure. So because our lowest common denominator here is 120, this is what we have here. It's going to be 120. Then for this, divided by 120, it's going to be times 3. For this, divided times by, to make it 120, times by 3. And this one is times by 2. So this is what we're going to have. So our resistors in parallel, to swap them around, is going to be 120 divided by 9. So that is going to give us 13.33 ohms. Okay. So let me just see. So basically that's what we've done, guys. But I think that because our time is up now, we can do some of the problems to after our test tomorrow. This will give you guys enough time for you guys to go and read through your work and see what you understand. So which means that from the next lesson on Monday, we're going to continue from these problems. Okay, we're going to continue from number 8. This is number 8 that we just did now, and we're going to continue with number 9 from Monday morning. So please, guys, make sure that you do that, and we'll see how it goes. Okay, so please be prepared for tomorrow. Study your work, energy, and power problems, and do these problems as well. But we're going to do problems up until the parallel circuits. We're not going to be doing series parallel because we haven't done the calculations thereof. Okay, so thank you guys so much for a beautiful class. This is a physical sciences grade 11 class. Hope that everybody is good and is more understanding than they were before they came here. My name is Nonkululeko Madondo. I am the physical sciences grade 11 teacher, and thank you guys so much for a beautiful classroom. Thanks and goodbye.